Okay, so another thing I need to talk about is there's a bunch of memorization you're going to have to do, which will help you in the next sections that we'll cover. So one of the things you'll learn is that when some elements become ionized, they'll lose 1 or 2 electrons or maybe gain 1 or 2 electrons. That element may be a single atom. If it loses or gains electrons, it would be considered a monatomic ion. But you can have groups of atoms that will lose or gain electrons. And so when you have groups of atoms, it's called a polyatomic ion. So the problem is, in the chemistry class that you're in, you have to memorize the names for all these polyatomic ions that I have here. So, for example, carbonate is one. The ion is called carbonate. Its formula is CO3 2-. So let me explain what that kind of looks like. So one way you can think of it is, here's a carbon atom in the center, and then there's 2 bonds to 1 oxygen, 1 bond to another oxygen, 1 bond to another oxygen. And so you can see that there are 3 oxygens there bound to the carbon. But we have to indicate in the structure that it has 2 extra electrons as indicated in the formula. It's 2-, so I put square brackets here, and I put a 2- there. Now let's take another example. Let's take hydroxide. So hydroxide is a little simpler. It's O bound to H, like that. And then there are brackets, and to indicate it has an extra electron, we put a negative sign there. There are a few polyatomic ions that are positively charged, meaning that they're maybe missing 1 electron than normal. Ammonium is one, which is down here. It might look like this, or does look like this. N bound to H, bound to H, bound to H, bound to H. And then we put brackets around that and indicate that it's missing an electron, so it has a positive charge. And then there are a bunch of others that are there in the list. So it's unfortunately a pretty lengthy list. So the question is there any way, anything that can help us sort of associate the forms with the names? And there's one thing that could help. So I'll get to that in just a second. But here, just a note, this list isn't quite complete. There are 2 more ions. The full list is located on the website, and there's a page which I've indicated here. And so basically this upper portion of the list is what I showed you in the previous slide. And then there are 2 others that you need to know. One polyatomic ion is called borate. It's boron with 3 oxygens attached, and it has a 2- charge. And then there's iodate. It's iodine with 3 oxygens attached, and it has a negative charge. So don't forget those 2. Okay. So let me tell you a few rules that might be helpful in memorizing the name associated with the formula for some of these ions. And so what you'll kind of notice is that oftentimes there'll be a group of ions that seem kind of similar to one another. And maybe the way that they might be different is either they may be varying the number of oxygen atoms, but they seem to have the other atoms are the same and the charges are the same, or maybe there's an addition of a hydrogen. So those are possibilities. So what I want to kind of do is kind of focus in on the first case. So there at the lower part of the list, we have a bunch of polyatomic ions, and all they're doing really is sort of varying in the number of oxygen atoms. And that is a group of polyatomic ions which is related to one another. And so one of the things you'll note is they all have oxygens, and they all have negative charges. And so you can sort of call this group of polyatomic ions, we can call these oxyions. And so the names you can look at are pretty similar. So let's look at this one here, chlorate, CHLORATE. And it has this formula, ClO3, and it has a negative charge. And what you'll kind of look is that you'll have similar names. They have sort of similar the chlorine, but with different suffixes or prefixes. So the next one up, the suffix has been changed from ate to ite, and then the next one up, we're adding a prefix, which is hypo. And then the one below the chlorate keeps the ate suffix, but then has a new prefix, which is per. So what do we do about that? Is there something that will help us remember this? So what I might suggest you do is there's some polyatomic ions that I strongly suggest that you just completely memorize the name and the formula for. So I call these norms, for lack of a better word for that. So chlorate is one that you should memorize. And so, for example, you can get an index card and you can write chlorate on one side, and on the other side of the index card, write ClO3-. So another 8 that I suggest you memorize is carbonate, which is not Cl, it is CO3-. So you can see it's going to be different. So but you have to remember that carbonate is not ClO3-, it's CO3-. And then I also have sort of circled here these 8s that you should just flat out memorize. I call them norms. And so if you just put those on cards and write a name on one side and the formula of the charge on another, that could help. But again, you're responsible for knowing all the rest, so might as well put all the rest on the cards as well. But let me give you a few quick rules that might be helpful. So again, we have these norms here. We have an 8, chlorate, that is the norm, and it's ClO3-. Now, one thing I want you to notice, let's say that you take an 8, which has 3 oxygens. It may not necessarily have 3 oxygens. In other polyatomic ions, it has different number of oxygens. But in the case of chlorate, it has 3 oxygens. Now, let's say that you want to add an oxygen to it to get that formula, which is ClO4-. If that is the case, if you add an oxygen, you keep the 8 suffix, but then you add the per prefix. So now you're at perchlorate. And so the formula for perchlorate is ClO4-. Now, back to the norm, the 8, the chlorate. If you remove an oxygen, now you're down to 2 oxygens. And so when you go down 1 oxygen from the norm, you change the suffix from 8 to ite. You don't add a prefix though. So you're now gone from chlorate, 1 less oxygen, you're now at chlorite. If you remove another oxygen, you're down to ClO. And so if that is the case, you keep ite and then add a new prefix, hypo. Hypo means under or less than. So if we're 2 oxygens below the norm, then you're going to be at hypoite. Okay, now one thing to sort of notice with all these formulas, which makes things a little bit easier, with all these formulas, that when you're changing the oxygen number in these oxyanions and you're changing the name, the charge remains the same, and that is always true. So there's always negative charge, which is really kind of helpful. Now let's look at another example. So carbonate there, we have CO3-. So let's say you see a formula and it's HCO3. Now, how can you remember some details of that? So one thing to remember is if you take CO3, 2-, and you're adding an H, you're really not adding a hydrogen atom, you're really adding a H+, a hydrogen atom that's missing electrons. So it's H+, and so if you're adding the hydrogen, the H is stuck onto the CO3, but we're adding a plus to the 2-, so now we're down to a single negative. And so that is the correct formula for HCO3-. Now, how do you change the name? So the simple way to do it is if you're adding an H+, then you just say hydrogen carbonate ion. For reasons that I don't understand, some of the earlier chemists said, well, if we're adding an H to a polyatomic ion, let's give it the prefix bi. So another equally good name for this polyatomic ion, HCO3-, is bicarbonate. And so you actually may recognize bicarbonate. You might have heard the phrase sodium bicarbonate. That is baking soda. Okay. So those are some things that are kind of helpful. So now let's just kind of test your knowledge. Okay, so question, for the imaginary element AB, the formula for the oxyanion named abdicate is AbO2 2-. What would be the name for AbO2-? Okay, so you have some choices there. So let's sort of talk about what I had just mentioned and kind of walk through this to see if we can come up with an answer. So the norm is the 8 ion, it's abdicate. Now in this case, it has 2 oxygens as the norm. It's AbO2, and the charge is 2-. Now, what you can see for the name where we have AbO2-, we're going down one oxygen and the charge is staying the same. So this is good news. So remember for that rule, if you go down one oxygen from the norm, all you have to do is change the suffix -ate to -ite. So the name of that AbO2- should be abdicite. Okay? The other ones are not quite right. Now, if we were to say have AbO3-, what would that be? Well, then we're going up from the norm, which is AbO2-, and so there it would be, you keep the -ate suffix and then add per, so that would be per abdicate. Okay, let's do another one. Okay, final question. If AbO2- is abdicate, could there be an oxyanion called hypoabdicite? Okay, so this is a bit of a trick question, so let me kind of walk you through the answer here. So when we have AbO2-, it is abdicate. Now, if we remove one oxygen, it will still be 2-. This will be abdicite. And so you're saying, oh, okay, it's easy to go down one more and get the hypo, right? We just remove one oxygen. So if we remove that one remaining oxygen, we would have Ab, but here's the problem. There are no more oxygens there, so it's not really an oxyanion, so we can't really name that with the rules we just learned, so the answer is no. Okay, well, thank you for listening. We'll see you next time.